Look up at the night sky, a vast, dark canvas, sprinkled with countless points of light. For as long as we've been human, we've wondered, are we alone? Are there other worlds like ours among those distant stars? This curiosity is woven into our very being. We are explorers, thinkers, and dreamers. The desire to reach out and find our place in the universe has driven us from the very beginning. Ancient storytellers imagined journeys to the moon and beyond, filling the heavens with possibility. As our knowledge grew, so did our dreams. We built telescopes, saw planets as worlds, not just wandering stars. The question shifted from if there were other worlds to which ones we might one day visit. The 20th century turned this ancient dream into a tangible goal. We took our first steps off our world. Robotic emissaries explored our planetary neighbors, sending back images of alien landscapes. We landed on the moon and brought back pieces of it. Each discovery fueled our imagination further. The dream of living on another planet became a question of science and willpower. The cosmos was calling, and we were learning how to answer. Of all the worlds in our solar system, one has captured our imagination more than any other. It's a world that feels both alien and strangely familiar, a place of stories, adventure, and the search for life. This world is our neighbor, the fourth planet from the sun, Mars. To this rusty, red world, our dreams of a second home have turned. The dream is no longer just to visit, but to stay. To transform a barren desert into a living, breathing world. To make Mars green. Mars hangs in our sky like a small red ember, its color the result of iron oxide or rust covering its surface. Images from our robotic explorers reveal a world painted in red, orange, and brown, a stark, desolate beauty. Mars is a world of extremes, incredibly cold, with an average temperature of -62 degrees Celsius. Its thin atmosphere, about 100 times thinner than Earth's, can't hold heat and offers no protection from radiation. The air is mostly carbon dioxide, with almost no oxygen. Water can't exist as a liquid on the surface for long. It boils away into the thin air. Yet Mars wasn't always this way. Ancient riverbeds and dried-up deltas tell us that, long ago, Mars was warmer and wetter. It had a thicker atmosphere and flowing water. The red planet holds the ghost of a world that might have once been like Earth. This gives us hope. The ingredients for a habitable world might still be there, locked in ice and dust. Waiting. How could we turn a cold, dead world into a living one? The idea, once pure science fiction, is now a serious, scientific pursuit. The process is called terraforming, earth-shaping on a planetary scale, the goal to create a place where humans could one day live and breathe without a spacesuit. Terraforming Mars isn't about building domes, it's about changing the entire planet. It would unfold over centuries, even millennia. The dream is to see blue skies, flowing rivers, and green forests on Mars. This would be humanity's greatest project, requiring unprecedented cooperation and vision. Like gardening, we'd need to prepare the ground, provide water, and ensure warmth. We'd have to warm the planet, thicken its atmosphere, and introduce life. The vision of a green Mars motivates our exploration and challenges us to think bigger. It's a dream of creation, turning a silent red desert into a vibrant, living world. The first step in terraforming Mars is to warm it up. Mars is trapped in a deep freeze. Nothing else can happen until we raise its temperature. One idea: use the greenhouse effect. Mars has carbon dioxide, but its atmosphere is too thin. We could release greenhouse gases, trapped in the polar ice caps, frozen carbon dioxide, or dry ice. Heating these caps would release gas, thickening the atmosphere and trapping more heat. Giant mirrors in orbit could focus sunlight onto the poles, starting the warming process. Factories could pump out powerful man-made greenhouse gases to boost the effect. As Mars warms, water ice beneath the surface could begin to melt. The goal: raise the temperature above freezing, so liquid water can flow again. This would be a monumental turning point for Mars. Once Mars begins to warm, the next task is building a proper atmosphere. A thicker atmosphere means stable liquid water, protection from radiation, and eventually, air we can breathe. Releasing carbon dioxide from the poles thickens the air, but it's still unbreathable. We'd need to add nitrogen, possibly from frozen nitrates in the soil. The hardest part, generating oxygen. Here, life becomes our tool. Hardy organisms like lichen and bacteria could survive on Mars, performing photosynthesis and releasing oxygen. Over centuries, these pioneers would slowly enrich the air. As oxygen rises, we could introduce more complex plants, forests of genetically engineered trees. These would accelerate oxygen production. The Martian sky, once thin and pink, could eventually turn blue. Step by step, Mars would become more like home. The transformation would take generations, but the process would be underway. Even with warmth and air, Mars's red dust isn't soil, it's lifeless rock. To create a green Mars, we must build living soil from scratch. On Earth, soil teems with microorganisms, fungi, and worms, recycling nutrients and sustaining life. The first Martian soil makers would be the lichens and microbes we introduce. As they grow and decompose, they'd add organic material and break down rock, slowly creating soil. We'd speed up the process by introducing bacteria that fix nitrogen, and, eventually, earthworms to aerate and enrich the ground. Once a basic soil layer forms, we could plant crops, first in greenhouses, then in the open as conditions improve. Imagine the first fields of wheat under a Martian sky. Fertile soil would be the final link, allowing a self-sufficient human presence on Mars. The dream of a green Mars is inspiring, but the challenges are monumental. Terraforming means changing the fundamental nature of an entire world, requiring more energy than our civilization currently produces. We'd need technological breakthroughs and a global commitment lasting centuries. There are ethical questions. Is it right to impose our will on another planet? Mars is a pristine, scientific treasure. If we terraform, we erase its ancient record, and might destroy native Martian life if it exists. The risks are huge. Planetary systems are complex. Our models could be wrong. We might trigger runaway warming or stall the process, leaving Mars in a dangerous half-formed state. The project could fail, leaving a planetary mess for future generations. Terraforming would take hundreds or thousands of years, a multi-generational effort. Each generation would have to maintain the vision, investing in a dream they may never see completed. Can humanity sustain such a long-term vision? It would require a fundamental shift in how we see ourselves and our place in time. Despite the challenges, the promise of a green Mars shines as a beacon of hope. Imagine, centuries from now, a new world with blue skies, oceans, and green fields. A second habitable planet would change our species forever, our ultimate insurance policy against disaster. Mars would be a new frontier for civilization, culture, and evolution. Life on Mars would be different, lower gravity, new societies, and perhaps even a new branch of humanity. The project would require global cooperation uniting us in a common purpose. The technological advances would benefit life on Earth as well. A green Mars would be the triumph of life and intelligence, a second garden in the cosmos. It's the continuation of evolution, guided by human hands. Our gift to the future, a new oasis in the vastness of space. The journey to a green Mars begins with the dreams we have today. It starts with those who look up at the night sky and wonder. The path ahead is filled with challenges and questions we can't yet answer. But every great leap in history started as an impossible dream. The dream of terraforming Mars forces us to confront our purpose and responsibility in the universe. In dreaming of other worlds, we learn more about our own. Perhaps we'll never see a green Mars in our lifetimes, but the dream itself is valuable. It inspires us to learn, explore, and innovate. The journey is as important as the destination, so keep looking up. Dream of red deserts turning to green fields, and of a future where humanity has two homes among the stars. The cosmos awaits. Have you ever built something incredible? Maybe a model rocket, or a go-kart from spare parts. That feeling, turning raw materials into something that works, is at the heart of being a builder, a maker, an engineer. We see problems and ask, how can I build a solution? We look at the world for what it could be. Now, imagine scaling that up. Not just a garage project, but a whole planet. Picture pointing at a distant dot in the night sky and saying, we're going to rebuild that. That's planetary engineering, the ultimate build. It's transforming a cold, barren world into a place where humans could walk, breathe, and maybe even plant a garden. It's audacious, ambitious, and fascinating. This isn't just science fiction anymore. Real scientists are asking if we can do it. We've climbed mountains, dived oceans, walked on the moon. The next step? Other planets. But those worlds are hostile, too cold, unbreathable air, no life-sustaining environment. So, the question, can we build one? Transforming a planet sounds like myth, but it's about pushing the limits of science and engineering. It's the grandest, most complex project humanity could ever attempt, the ultimate workshop project where all of humanity is the build team. So let's grab our safety goggles and see how we might pull it off. So, what is planetary engineering? At its core, it's a massive renovation project. Think of it like fixing up an old house with good bones, but unlivable conditions. You wouldn't just move in, you'd fix the plumbing, install heating, and make the air breathable. Planetary engineering, or terraforming, is the same idea, just on a planetary scale. Take Mars. Its plumbing is frozen water, its heating is a thin atmosphere, and the air is mostly carbon dioxide. The job is to fix all that, kick-starting natural processes to make the planet more like Earth. The dream? A shirt-sleeve environment, where you could walk outside without a spacesuit. To get there, you need a thicker atmosphere, the right mix of gases, liquid water, and a stable climate. Each is a monumental engineering challenge, but this isn't about making a perfect Earth copy. Every planet is unique. The goal is a custom build, a Mars that's habitable for humans and Earth life. We'd nudge the planet's systems, then let physics and chemistry do the heavy lifting over centuries. It's the ultimate long-term project. We're not just building habitats, we're changing worlds. It's about working with what you've got, not starting from scratch. The checklist is huge, but the payoff could be even bigger. That's planetary engineering in a nutshell. When it comes to changing a planet, Mars is always the first candidate. It's the most Earth-like planet in our solar system, our next-door neighbor. Mars has a day almost as long as ours, polar ice caps, and evidence it was once warmer and wetter. Billions of years ago, it had a thick atmosphere, rivers, maybe even an ocean, but its core cooled, the magnetic field faded, and solar winds stripped away the atmosphere. Mars became cold and barren. Terraforming Mars is a planetary restoration project. The raw materials, water ice and carbon dioxide, are still there, locked in the poles and soil. The idea, trigger a greenhouse effect on purpose, release greenhouse gases to trap heat, warm the planet, and thicken the atmosphere. As Mars warms, ice turns to gas, accelerating the process. Eventually, water ice melts, rivers flow, and lakes form. We'd start with hardy microbes and lichen to produce oxygen, slowly changing the air. It's a long, slow chain reaction. We'd just be there to kickstart. So, how do you actually terraform a planet? It's a step-by-step process. First, the warm-up phase. Thicken the atmosphere and trap heat to raise temperatures above freezing. Without warmth, nothing else happens. Next, the water phase. As temperatures rise, frozen water melts, creating rivers and lakes. Liquid water is essential for life and climate. Then comes the green phase. Seed the planet with tough, engineered microbes and algae. These pioneers perform photosynthesis, turning carbon dioxide into oxygen. This process is slow, centuries or millennia, but it's the only way to make breathable air. Finally, the habitation phase. Once oxygen levels are high and the climate stable, introduce more complex plants, then animals, and, eventually humans. Each step builds on the last, in a deliberate planetary-scale construction project. It's not a quick fix, it's a marathon. Every phase is a milestone and each requires patience and precision. The transformation is gradual, but the end goal is a living, breathing world. It's the ultimate engineering challenge, and it all starts with a plan. To terraform a planet, you need tools on a scale we've never built. One idea, giant orbital mirrors. These reflect sunlight onto the surface, vaporizing ice and releasing greenhouse gases. Another, impact-driven terraforming, redirecting comets or asteroids to crash into the planet, delivering water and gases in one explosive move. On the ground, automated factories mine resources and pump out greenhouse gases, thickening the atmosphere steadily. The biological toolkit is just as important. Gene labs engineer extremophile microbes to survive and thrive, producing oxygen. Delivery systems, rockets or probes, spread these organisms across the planet. It's a mix of brute force engineering and delicate biology. Every tool has risks and rewards. The right combination could turn a dead world into a living one. It's a planetary-scale toolbox for the ultimate renovation, and we'd need every tool we can invent. In any build, things go wrong. On a planetary scale, the stakes are enormous. The biggest myth? That it's a smooth, predictable process. We barely understand Earth's climate, let alone another planet's. Overshoot the warming, and you risk a runaway greenhouse effect, turning Mars into a new Venus. Or, the new climate could be violently unstable dust storms, acid rain, or mega hurricanes. There could be toxic chemicals released, or even dormant Martian life revived. Our actions could wipe out native life before we even find it, or trigger unpredictable clashes between Earth and Martian microbes. Every step is a leap into the unknown. The law of unintended consequences rules here. Planetary engineering is as much about managing risks as building dreams. Problems are inevitable. The real test is how we solve them. Planetary engineering would be a constant cycle of measurement, modeling, and correction. We'd need a vast sensor network, satellites and ground stations monitoring everything. Supercomputer models would predict the planet's future climate, letting us adjust course. If things get too hot, deploy sunshades in space or release aerosols to reflect sunlight. If too cold, ramp up greenhouse gas production or re-aim orbital mirrors. It's a delicate balancing act, managing dozens of variables, not just temperature. A terraformed world would need active management for millennia. We'd be its gardeners and mechanics, always ready to tweak and maintain. The project never really ends. It just shifts from construction to stewardship. Here's the twist. We're already planetary engineers, just not on purpose. For 2 centuries, we've been running an uncontrolled experiment on Earth: climate change, burning fossil fuels, deforestation, pollution. We're altering our planet's systems. The results: rising temperatures, melting ice, extreme weather. It's a small-scale rehearsal for terraforming, complete with unintended consequences. But it's also a learning opportunity. As we tackle climate change, we're developing the tools and knowledge for planetary engineering. Climate models, renewable energy, even geoengineering, all skills we'd need on Mars. Before we terraform another world, we must prove we can manage our own. Fixing Earth is the ultimate practice run. If we can't get it right here, we're not ready for Mars. After all these challenges, why even try? The answer: survival and ambition. Earth is our only home. A disaster here could end humanity. A second self-sufficient home, like a terraformed Mars, is the ultimate insurance policy. It's not about abandoning Earth, but backing up humanity. There's also the spirit of exploration and the challenge itself. Pushing boundaries drives progress, just like the moon race did. Terraforming Mars would spark breakthroughs in energy, materials, genetics, and climate science. The dream is bigger than survival. It's about becoming a species that creates and nurtures worlds. It's a vision of humanity as cosmic builders, bringing life to the stars. It forces us to think bigger, plan for generations, and see ourselves in a grander story. For builders, it's the boldest dream there is. For centuries, Mars has been a canvas for our wildest dreams and deepest fears. The red planet has captured the human imagination like no other world in our solar system, inspiring countless stories, myths, and scientific quests. From the earliest astronomers peering through primitive telescopes to modern-day scientists sending robotic explorers, Mars has always beckoned us with its mysterious glow. Once, we imagined Martian civilizations. Artists and writers filled pages with visions of canals, alien life, and bustling cities beneath a dusty sky. These fantasies reflected our hopes and anxieties, projecting our own dreams onto a distant world. Now, we dream of building our own. The idea of humans living and thriving on Mars has shifted from science fiction to a real possibility, fueled by technological advances and a renewed spirit of exploration. The idea of becoming a multiplanetary species is both thrilling and daunting. It challenges us to push the boundaries of what's possible, to imagine a future where humanity is not confined to Earth alone. Mars is Earth-like, yet utterly alien. Its landscapes hint at a dynamic, watery past. Ancient riverbeds and vast canyons suggest that water once flowed here, raising tantalizing questions about the possibility of life. To set foot on Mars would be a leap as great as our first steps on the Moon. It would mark a new era in human history, a testament to our curiosity and determination to explore the unknown. But this dream is about more than adventure. It's about survival. As we look to the future, Mars offers a chance to ensure the long-term survival of our species, to become stewards of life beyond Earth. Spreading life beyond Earth could safeguard our future. By reaching out to Mars, we take the first steps toward becoming a spacefaring civilization, resilient in the face of cosmic challenges. Yet, Mars is a hostile world, cold, dry, and unforgiving. Its thin atmosphere and harsh climate make survival a formidable challenge, demanding ingenuity and perseverance. Turning this vision into reality means confronting immense challenges. Every step forward requires new solutions, from life support systems to sustainable habitats and reliable transportation. We must approach Mars with the clear eyes of scientists and engineers, not just dreamers. Careful planning, rigorous testing, and international collaboration will be essential to our success. The thin air, brutal cold, and relentless winds test the limits of our technology and endurance. Radiation, scarce water, and vast distance from Earth add to the complexity, making every mission a high-stakes endeavor. All stand in our way, demanding innovation and resilience at every turn. Only by understanding these obstacles and working together to overcome them can we hope to thrive on the red planet and turn our Martian fascination into reality. On Mars, taking a breath would be fatal. The very air that surrounds you is not just unbreathable, it's actively hostile to human life. Imagine stepping outside and feeling the weight of emptiness pressing in, knowing that a single crack in your suit could be the difference between life and death. The Martian atmosphere is 100 times thinner than Earth's, a ghostly wisp made almost entirely of carbon dioxide. There's barely any pressure to speak of, and the air is missing the oxygen we need to survive. Without a pressurized suit, your blood and body fluids would literally start to boil away in seconds, as if you'd stepped into a vacuum. The human body is simply not built for such extremes. Even if you could somehow survive the pressure, the air itself is toxic, filled with suffocating carbon dioxide and not a trace of oxygen to breathe. Every breath would be poison. That's why any Martian settlement must be a sealed bubble, a fragile oasis of Earth-like air in a deadly desert. Every habitat is a lifeline, separating us from the hostile world outside. The thin atmosphere offers almost no protection from meteors or cosmic radiation. Habitats must be built strong, or even buried beneath the surface, to shield against constant threats from above. Mars's sky is a shooting gallery, with meteors streaking through the thin air, unimpeded by the kind of atmospheric shield we take for granted on Earth. The atmosphere also can't hold heat. Imagine wrapping yourself in a paper-thin blanket on a freezing night. The cold seeps in relentlessly, and there's nothing to stop it. Sunlight that warms the surface during the day quickly escapes back into space at night, leaving the ground exposed to wild, often dangerous temperature swings. There's no greenhouse effect to stabilize the climate. Mars can't trap the sun's warmth, so temperatures plummet as soon as the sun sets. The result is a world of extreme, life-threatening cold where survival depends on technology and constant vigilance. Surviving on Mars means engineering our own safe, warm environment from scratch. Every wall, every seal, every system is a barrier between us and the planet's deadly embrace. Every breath, every moment outside, is a battle against the planet itself. The simplest tasks become high-stakes challenges in this unforgiving world. The Martian atmosphere is not just thin, it's an ever-present danger, a constant reminder that Mars is a world where survival is never guaranteed. Mars is a frozen desert, colder than Antarctica. Average temperatures hover at -63 Celsius. A power failure means instant deep freeze. Survival depends on constant heat. Daytime at the equator can be mild, but nights plunge to -73. These wild swings stress every material and machine. Solar panels provide power, but dust storms can block sunlight for weeks. Reliable backup, like compact nuclear reactors, is essential. Spacesuits and habitats must be perfectly insulated. Every tool and vehicle must withstand the relentless cold. Stepping outside is a major operation, not a casual stroll. The Martian cold is a constant energy-draining threat. On Mars, warmth is life, and it's always in short supply. Mars offers no protection from cosmic and solar radiation. Without a magnetic field or thick atmosphere, astronauts face a constant shower of high-energy particles. Galactic cosmic rays and solar eruptions can damage DNA and threaten health. The best shield is mass. Habitats may need to be buried under meters of Martian soil. Advanced materials and even artificial magnetic fields are being explored. Biomedical research aims to boost our resistance to radiation. The journey to and life on Mars both carry unavoidable health risks. Until we solve radiation, every day on Mars is a gamble with ourselves. Surviving the invisible storm is one of our greatest challenges. Water is life, but on Mars, it's locked away as ice. Liquid water can't survive on the surface, it boils away instantly. Yet, Mars hides vast reserves of frozen water at its poles and beneath its soil. The challenge, extracting and melting this ice, requires energy and technology. Future settlers must become expert water miners, using robots to locate and harvest ice. Purified water will be essential for drinking, growing food, and life support. Through electrolysis, water can be split into oxygen for breathing and hydrogen for fuel. This enables in-situ resource utilization, making air and rocket fuel on Mars. Water is the cornerstone of a self-sufficient colony. Every drop must be recycled and reused. Mastering Martian water is key to survival and independence. Mars is staggeringly far, up to 400 million kilometers away. A one-way trip takes 6 to 9 months, with launch windows only every 26 months. Every supply must be planned and shipped years in advance. Once on Mars, settlers are truly on their own. No quick rescues, no overnight deliveries. Communication delays mean no real-time help from Earth. Astronauts must be highly autonomous, solving problems without backup. The fragile supply chain makes self-sufficiency essential. Settlers must extract water, make air, build with Martian soil, and grow food. Every kilogram not launched from Earth saves money and reduces risk. Independence from Earth is the only way to survive long-term. Surviving on Mars means building a new world from scratch. Early habitats will be inflatable modules from Earth, expanded on the surface. For long-term safety, habitats must be buried under Martian soil for radiation protection. Robotic bulldozers and 3D printers can prepare sites before humans arrive. Eventually, we'll build with Martian materials, turning regolith into bricks and glass. Closed-loop life support will recycle water and air, using plants to produce oxygen and food. Every resource must be reused. Waste becomes survival. This technological ecosystem is the key to breaking our dependence on Earth. Only by mastering these systems can we create a permanent home. On Mars, engineering is survival. The greatest challenge may be psychological, not physical. Mars missions mean years of isolation in a small habitat, millions of kilometers from home. The crew must endure monotony, confinement, and separation from loved ones. Teamwork and emotional resilience are essential for survival. Strategies include virtual reality escapes, care packages, and comfortable habitats. Growing fresh food offers both nutrition and comfort. The right crew, with the right support, can overcome even profound loneliness. Success depends on the strength of the human spirit. Mars will test not just our technology, but our hearts and minds. Turning a survival pod into a true home is the ultimate human challenge. Living in habitats is just the beginning, an incredible first step in humanity's journey to become a multi-planet species. But for many, the real dream goes far beyond simply surviving inside domes and artificial shelters. The ultimate dream is to terraform Mars, to transform this cold, barren world into a place that feels like home, a living, breathing planet where life can truly thrive. Terraforming means changing Mars so completely that humans could one day walk its surface without bulky suits, surrounded by green landscapes and blue skies, just as we do on Earth. The first step is to thicken the thin Martian atmosphere and warm the planet by releasing the carbon dioxide trapped in its soil and polar ice caps, creating a powerful greenhouse effect. Some ideas to jumpstart this process include placing giant mirrors in orbit to reflect sunlight onto the surface, helping to melt the ice and release more gases. Others suggest spreading dark material on the ice caps to absorb more heat, accelerating the warming process and speeding up the transformation. As the greenhouse effect intensifies, water could once again flow on the Martian surface, filling ancient riverbeds and creating lakes and seas where none have existed for billions of years. Eventually, humans might be able to step outside with just an oxygen mask, feeling the warmth of a new sun and the breeze of a new world on their faces. The hardest step of all will be making the air truly breathable, by seeding Mars with specially engineered microbes and hardy plants that can survive the harsh conditions and slowly produce oxygen. Over thousands, even millions of years, these organisms could gradually turn carbon dioxide into oxygen, transforming the Martian atmosphere into something we could breathe. Terraforming is a dream for the far future, a vision that will require patience, innovation, and generations of effort. But it gives our journey to Mars a sense of purpose and hope, inspiring us to push the boundaries of what's possible. Spreading life to Mars is humanity's boldest vision yet, a testament to our creativity, our courage, and our desire to shape the future among the stars. Imagine opening your eyes, not to Earth's blue sky, but to a soft reddish glow filtering through a reinforced viewport. The world outside is silent, alien, and breathtakingly beautiful. You're not just waking up in a new place, you're waking up on an entirely new world, millions of kilometers from home. The familiar sounds of birds or city life are replaced by the gentle hum of life support systems and the distant creaks of your habitat adjusting to the Martian dawn. This is morning on Mars, a silent panorama of rust-colored dust, ancient volcanoes, and endless plains beneath a pinkish sky. The sun rises weakly, casting long shadows and painting the landscape in surreal hues. Every sunrise here is a reminder that you're standing on the edge of human exploration. Your home is a habitat inside a pressurized dome or carved into a Martian cavern, designed to shield you from the planet's harsh environment. Every wall, every window, is a barrier between you and the unforgiving world outside. The air you breathe and the water you drink are manufactured and recycled, the result of careful engineering and constant vigilance. Every drop and every breath is precious, a product of technology and teamwork. Every day is a dance with physics and engineering. Even stepping outside means donning a life-supporting spacesuit. The simple act of going for a walk becomes a carefully planned mission, with safety checks and backup systems. The silence is broken only by the hum of your suit and your own breathing, a constant reminder of your dependence on technology. The isolation is profound, but so is the sense of wonder. Mars is harsh, thin air, freezing cold, and constant radiation. But here we are, building a society from scratch. Every structure, every tool is a testament to human ingenuity and resilience. The first settlers are scientists, engineers, doctors, and farmers, all working together to make Mars a permanent home. Their days are filled with experiments, repairs, and the shared dream of a thriving colony. Daily life mixes the mundane with the extraordinary, cooking, cleaning, and streaming shows, all while standing on the frontier of human experience. Even leisure time is different here, shaped by the challenges and wonders of Martian life. It's a life of purpose and sacrifice, defined by the hum of machinery and the taste of hydroponic vegetables. Every meal is a small victory, a reminder of how far we've come. Nights bring two moons, Phobos and Deimos, streaking across the sky. Their orbit's a nightly spectacle unique to this world. The Martian night is cold and quiet, but filled with a sense of possibility. Your children may be the first true Martians, born under a different sun, growing up with new traditions and dreams shaped by this alien world. This is the reality we're exploring, humanity's first steps beyond Earth, forging a new chapter in our story, one sunrise at a time. On Mars, survival starts with the basics: air, water, and food. These are the foundations of life, and on the red planet, each one is a daily challenge that demands constant attention and innovation. The Martian atmosphere is thin and mostly carbon dioxide. Breathing it is fatal. There's almost no oxygen, and the air pressure is less than 1% of Earth's, making it impossible for humans to survive outside without protection. Machines like Moxie act as robotic trees, splitting CO2 to create oxygen for our habitats. These devices are essential, working around the clock to ensure a steady supply of breathable air. Every breath is a product of technology. Air is constantly scrubbed and recycled. Sophisticated filtration systems remove contaminants, keeping the atmosphere inside habitats safe and healthy. Water is just as precious. Most of it is locked away as ice at the poles or underground, hidden beneath layers of rock and dust, far from easy reach. Robotic miners extract ice, which is melted, purified, and stored. This process is energy-intensive and requires careful planning to ensure a continuous supply. Every drop is used for drinking, farming, and hygiene, then reclaimed and recycled. Water is monitored closely and nothing is wasted, as even a small loss could be critical. Advanced water systems purify wastewater, making yesterday's coffee tomorrow's drink. These closed-loop systems are vital, turning waste into a resource and ensuring the colony's survival. Food comes from high-tech hydroponic farms, no soil, just nutrient-rich water and LED lights. These futuristic greenhouses allow crops to grow year-round, regardless of the harsh conditions outside. Crops like lettuce, tomatoes, and potatoes are grown indoors, their success vital to survival. Each harvest is a milestone, providing fresh food and a sense of normalcy, far from Earth. Nothing is wasted. Every resource is recycled in a closed loop. Waste from one process becomes the input for another, creating a delicate balance that must be maintained. These systems free us from the cost of shipping supplies from Earth. The more we can produce and recycle locally, the more independent and sustainable our colony becomes. On Mars, technology and resourcefulness are the difference between life and death. Every system must work flawlessly, and every crew member must be ready to adapt and solve problems as they arise. Every meal, every breath, every sip of water is a triumph of human ingenuity. These small victories are reminders of how far we've come, and how much we depend on our technology and teamwork. The basics are never taken for granted. Each day, the crew is reminded of the fragile balance that keeps them alive. Survival is a daily achievement. It's a constant effort, requiring vigilance, cooperation, and a deep respect for the resources that sustain life. This is how we build a self-sustaining colony on a hostile world. One breath, one drop, and one meal at a time. On Mars, your home is your lifeline. It's not just a place to sleep, it's your shield, your sanctuary, and your only refuge from a world that's as beautiful as it is deadly. Radiation is the biggest threat, so habitats are buried under Martian soil or built inside ancient lava tubes for natural shielding. The planet's thin atmosphere offers little protection, making these shelters essential for survival. Prefabricated modules from Earth are covered with regolith by robotic bulldozers. This thick layer of Martian soil acts as a protective blanket, blocking harmful cosmic rays and micrometeorites. Lava tubes offer vast, ready-made spaces, just seal and pressurize for city-sized shelters. These natural caverns could one day house entire communities, safe beneath the surface. Building materials come from Mars itself. Regolith is transformed into Marscrete by robotic 3D printers. Using local resources means habitats can expand and adapt as new settlers arrive. Inside, habitats are pressurized, with advanced lighting to mimic Earth's day and night. Carefully controlled environments help maintain physical and mental health for the people living there. These structures are self-contained biospheres, living quarters, labs, farms, and recreation, all under one roof. Every system is designed for efficiency and sustainability. Life inside is designed to feel as normal as possible, despite the alien world outside. Social spaces, familiar routines, and even shared meals help settlers stay connected to earthly life. Every wall is a barrier between life and the void. These reinforced structures are the only thing standing between humanity and the harsh Martian environment. These homes are humanity's first true outposts in the cosmos, a testament to our ingenuity, resilience, and our drive to explore new worlds. A Martian day is just over 24 hours. Life's rhythm feels familiar, but everything else is new. Adults work to keep the colony alive. Scientists study Mars, engineers maintain systems, and farmers grow food in vertical hydroponic gardens. Every job is critical. Mistakes can be deadly. Children learn reading, math, robotics, and life support engineering, skills for survival. Physical education happens in pressurized gyms, sometimes with simulated Earth gravity. After work and school, relaxation is vital meals in common areas, movies from Earth, and virtual reality escapes. Stargazing is a favorite pastime. The Martian sky is breathtaking with no light pollution. Community is everything. Isolation makes connection essential. Every day is a blend of routine and wonder. On Mars, work, learning, and play are all about adapting and thriving together. Moving to Mars isn't just relocation, it's a one-way journey. The trip takes 6 to 9 months, confined in a small spacecraft, watching Earth shrink to a distant star. Arrival brings awe and fear. Mars is magnificent, but alien and unforgiving. Life is confined, reliant on technology, and isolation can be intense. Communication with Earth is slow. Messages take minutes, not seconds. No real-time calls, just video messages and long waits for replies. Over time, homesickness fades, replaced by a strong Martian identity. Settlers bond deeply, forging new traditions and culture. Earth becomes a cherished memory, not a home. The emotional landscape shifts. Settlers become Martians. This is the price and promise of a new world. Mars will change us, culturally and physically. With only 38% of Earth's gravity, muscles and bones weaken without constant exercise. Settlers use resistance machines and artificial gravity to stay healthy. Children born on Mars may grow taller, with lighter frames and weaker hearts. They might never be able to visit Earth, their bodies adapted to Mars' gentle pull. Over generations, higher radiation could accelerate evolution, leading to new traits. Martians may develop resistance to radiation or other unique adaptations. We're witnessing human evolution in real time. Mars could give rise to a new branch of humanity, Homo sapiens Martis. The red planet will shape us in ways we can only begin to imagine. Early Martian society isn't about money, it's about survival. Everyone contributes: geologists, engineers, farmers, all working to keep the colony alive. The main export is data, scientific discoveries sent back to Earth. The colony is a remote laboratory, funded by Earth's governments and corporations. As self-sufficiency grows, a local economy may emerge. Credits earned for work, spent on comforts or personal projects. Mars's low gravity makes it a launch hub for missions to the asteroid belt and beyond. In time, Mars could become the industrial heart of the solar system. Work is about purpose, not profit. Every task builds the foundation for a new civilization. On Mars, survival and progress are the ultimate rewards. Martian society is built on collaboration. Everyone's survival depends on everyone else. Disputes aren't just personal, they're existential threats. Early governance is by council, focused on science and safety, not politics. Laws are simple, pragmatic, and enforced for the good of all. As the colony grows, democracy and diversity will shape its evolution. Culture blends Earth's traditions with new Martian customs. Landing Day becomes the biggest holiday. Art and music reflect the red landscape and the hum of life support systems. For the first generation, Earth is home. For their children, it's a distant legend. Eventually, Martians may declare independence, not out of conflict, but as a natural step. Humanity becomes a two-world species, each with its own destiny. Living on Mars is the next step in humanity's journey of exploration. It's a monumental challenge, demanding our best science, engineering, and spirit. Mars isn't just about adventure, it's about survival, a backup for our species. Colonizing Mars ensures humanity's story continues. Even if disaster strikes Earth, settlers and their children will be transformed, physically, culturally, and philosophically. They'll see Earth as a single, fragile world, inspiring us to care for our home. The pursuit of Mars will drive innovation and unite us in a common goal. It's a journey to understand ourselves and our place in the universe. Mars may be our future home, or simply our next great adventure. Either way, the journey is worth taking. Our destiny lies amongst the stars.